take a look at this problem here, and I'll go through a few different ways to approach it. All right, so first, if we start with rhombus ZQT, so all the sides are the same length. They have diagonals that intersect at point R. And there's nothing that specifies any angle measures for anything, so I can just label Z, Q, T, and P. As long as they're in consecutive order, I'm good. Right. I do know several things about a rhombus. Okay. The diagonals of any parallelogram bisect each other, so these two lengths are equal and these two lengths are equal. But with a rhombus in particular, those diagonals are perpendicular bisectors of each other, so there's going to be right angles here. Okay, now, when you look at each of these right angles that are formed here, I have 1 tick mark, 2 tick marks, 3 tick marks, and a right angle. Those are all congruent triangles. So one method that I have for calculating this is if I find the area of one of these triangles, I can multiply it by what? 4. So let's take a look at the measurements. So if I'm told that the diagonal, one diagonal has a length of 30. So it doesn't matter which diagonal you identify. I'm going to call it this long one here. And then the side length is 25. So if I know that each of these side lengths here is 25, and if this whole length is 30, then half of it represents this leg right here. So half of 30 is 15. And so that gives me this right triangle that's highlighted as a 25 and a 15. So I can use either Pythagorean theorem to solve for the other leg, or if I recognize this is 5 times 5 and 3 times 5, so I have this common triple, a 3 blank 5 or a 3 4 5 with a multiplier of 5, and that gives me 20 for this length. So what I could do is I could say that my total area for the rhombus is going to be 4 times the triangles. 4 times a triangle is 1/2 base times height. Half of 4 is 2. So I get 2 times my base right here of 20 times my corresponding height, which is 15. And so if I'm calculating it in this way, I get 30. 2 times 15 is 30 times 20 is 600. There are no units specified, so square units would be my solution. Okay, so that's one possibility. Okay, another possibility would be to see that this rhombus is made up of these two triangles. So PZQ and PTQ, those are congruent triangles. So I could also think of this as being an area made up of 2 triangles. So 2 times 1/2 base times height. If this is the case, then my total base is this length here, 30. So I would get a half and the 2 cancel. So I get my base to be 30, and my corresponding height is this perpendicular 20. 30 times 20 gives me 600 square units.